I am very happy, not only because Professor Bannon we shared some interest in the evolution of musicality, but it is not often the opportunity to have a lecture of a person who spent a lot of time in Australia and have a big experience, not only in science, because Professor Bannon is not only scientist, but he is also composer. But probably the most important achievement of Professor Bannon is the creation of a specific type of teaching singing. And I've brought with me 3 books that I would like to present you, authored by Professor Bannon. The first one is edited by Professor Bannon, but I'd like to present it because this is the book from which I got to know about Professor Bannon, and from this time I realized that our point of view is very close, in the thinking about the evolution of human musicality. But I have also 2 books. One is Every Child a Composer. This is a book which introduces the application of the evolutionary thoughts about music into music education, especially in education and singing. And this another book published by Oxford University Press, also authored by Professor Bannon, First Instrument, which is solely devoted to the teaching of singing. Let me switch for Polish for a while. Proszę Państwa, dla tych z Państwa, którzy, bo wykład będzie w języku angielskim i prezentacja też jest tutaj w języku angielskim, ale dzięki pani profesor Ewie Schreiber mamy tłumaczenie slajdów, które Państwo możecie znaleźć na stronie internetowej naszego Instytutu, w aktualnościach, tam gdzie jest tytuł tej prezentacji. No i chciałbym też podziękować naszemu wydziałowi za wsparcie finansowe z prowadzenia profesora Bannona, no i przede wszystkim Urzędowi Miasta Poznania, który dofinansował ten wykład. Nie będę zabierał więcej czasu, bo chcemy ten czas poświęcić na wykład i potem dyskusje są. Professor Bannon, the floor is yours.
Well, thank you very much, and it's wonderful to be here. I'm going to actually do the session from here so that you can see the screen. So we're going to look at the idea that music is an evolved part of the human condition, and there'll be several slides which put forward arguments for and 1 or 2 against that. So I want you to imagine knowing a little about the background to the evolutionary story. And I'm going to start here with these married couples. What can we say about this? The ones with the black fur are the males, the blondes are the females. And there they are singing in a chorus together, all adults. Possibly the one on the right is younger, but there they are. And I think we can consider that 18 million years ago, we shared ancestry with this species. This is the Hylobates gabrieli. It's a gibbon from Southeast Asia. And I couldn't get a recording of these gibbons singing, but a very closely related species we have, and we have to change the projection to allow you to hear them singing. And I want you to concentrate on the yellow female at the back and the 2 black females at the front, the contribution that they both make to this performance. That's a thrilling sound, and we will consider some of the reasons that a species would make these sounds and what links that to theories of the evolution of musicality in our species. So I'm going to take you back to the historical origins of our understanding of evolution. This man, Charles Darwin, who lived just south of London, began to write about natural selection in 1859 with The Origin of Species, and then later focused more on the evolution of human beings in his second major work, The Descent of Man. We have a first edition here, especially selection in relation to sex. The idea that what distinguishes our species, and think about those yellow and black gibbons, is that our behavior is conditioned by the relationship that we have that permits reproduction, attraction of mates, and the bringing up of the next generation of children and grandchildren in this culturally transmitted but also genetically transmitted manner. So we owe a lot to Darwin, and I'd like to say a little more about him. This is a picture made when he and his wife Emma were quite old. Emma Darwin was a pianist who studied with Chopin, the Polish composer who lived in Paris, where she studied with him, and also with a friend of his called Moscheles. She was arguably the finest female pianist in England of her generation. She never performed publicly, hardly, but every night she would perform for her husband. So what we now know about Darwin is that music was very much a part of his life, even though he himself didn't see himself as very musically able. Two of his sons were highly competent musicians, although one became a professor of botany at Cambridge and the other a professor of astronomy. But both of them tried to help interpret his ideas in relation to those of people like Helmholtz in the next generation after Darwin's death. So I'm going to introduce you to a perspective on the consequences of Darwin's theories. And the two statements at the bottom here I will repeat later so that we can consider how each of us feels about them when we've considered some of the evidence. My friend Ian Cross from Cambridge made this statement in one of his papers: is music the most important thing we ever did? I just love the simplicity of that. Would we be here if we hadn't acquired musicality? Or would we have died out, eaten by predators, or unable to relate to one another tribally and socially? So this acts as a way of looking at two different views of the consequences of Darwin's theory. We refer to these as weak and strong. Firstly, maybe music evolved as a side effect of the interaction between general intelligence and culture, and is thus dependent on an existing capacity for language. That interpretation of Darwin was quite early in its development after Darwin's first publications, and it's very much associated with Darwin's colleague and friend Herbert Spencer, the idea that music is what happens when you do things with language, but language is there first. Then there's a second characteristic, which is really what we're going to look at today. Musical behavior evolved prior to language due to anatomical adaptations in response to the environment that conferred advantages in vocal communication and perception, without which our species would not have survived. Right, so very briefly, I'm going to show you some characteristics of the fossil evidence. We could start at this corner, move across, round, and that's you and me there. Okay, I won't label all these, partly because I forget, and partly because if you want to check this out, there's plenty of sources. But here you have a very early ancestor, and you can see these brow ridges. I invite you to use your fingers, just feel what your face feels like in comparison with this. And the other thing, if you put your hand on top of your head, it's flat and smooth. whereas these had what we call the sagittal crest. It's a bony projection from the forehead to the back of the head. Why would it have these projections of bone here and here? It's to attach muscles that are strong enough to eat trees and plants. We've lost them because with other characteristics of upright posture and the development of the skull shape that comes in line with general intelligence that allows us to hunt and seek food and later to cook it through the use of fire, those things eventually became unnecessary. And forgive me for doing this, but they allow this to happen. We have resonant skulls. These do not produce sound even as bone structures in that same way. By the way, that's Lucy, 3 million years ago or so. This looks like us. I wonder why. This is important. It's a child. If this child had not died at that point in their lives, it would have acquired the brow ridges. So they are a sign of the development into adulthood for these species further back in history. This is interesting because it tells us that we as humans have these skull shapes and characteristics whereby even though we're bigger than our own children, we retain these. You'll see why I can say this in a moment. Next generation still got these features. The sagittal crest has gone here, although there's still a little bit, and let's be honest, some of us still have a little bit of this nowadays. And then we end up with these, the domed skull, the beautiful sort of spherical shape which resonates through when we sing and speak. So I'm going to use the chimpanzee species as a way of illustrating this comparison. This is a female chimpanzee. Notice that there's this very pronounced extension of the jawbone, and although you can't see it, the head still has these attachments to some extent. This is the same chimpanzee's child, and here you see something that reminds us of our own human children. I've shown this slide in some places and people go, ah, because we find an attraction to something that looks like us. Let's go back. This is what she will look like when she's that age. How do we know? Let's look at this. This is the chimpanzee child skull, human child skull. In terms of proportions and shape, they're very, very similar. Adolescent, adult. Look at the projection and enormous forces of change that turns this into the kind of adult that can survive in its environment, both in terms of protection against aggression itself. We know that chimpanzees can be cannibalistic. And by comparison, let's look at the relationship between the adult human skull and its own child. And there's, in terms of these proportions, this is bigger, but very little of that extraordinary change to the bone structure and the jaw have changed. Just going to throw that in. One of my favourite birds in Australia. I once heard one in Brisbane do this. I could have notated it. That's tonal music produced by a bird. And I know it worked because I heard it do it and then sing something else for 15 minutes and then sing that. It was its chorus. It was its identity. So let's go back to Darwin. He made the following statements, and I think it's useful to use his words, so I'll speak them. I cannot doubt that language owes its origin to the imitation and modification of various natural sounds, the voices of other animals, and man's own instinctive cries, aided by signs and gestures. A couple of important things. Animal imitation. I know you have songs about cuckoos in Poland. And signs and gestures. Vocal communication is not just with the voice, it's with the face. We look at each other, we see expression, and it's with the hands and the body. What we call multisensory perception of complex communication. Darwin went on, some early progenitor of man probably first used his voice in producing true musical cadences, that is, in singing. It is therefore probable that the imitation of musical cries by articulate sounds may have given rise to words expressive of various complex emotions. Okay, so I'm just going to lay down some illustrations of how we've investigated these responses to Darwin's theory. It's the first of our senses to prove interactive with the external environment and to lay down retrievable memories in the womb from 3 months before birth. Now, most of the work that's proved this has only happened in the last 30, 40 years. I've been very lucky to know some of the people who initiated this. Richard Parncut there, working in Vienna. He in turn is referring back to people like Sheila Woodward, who implanted microphones in her own womb. We're going to hear a recording in a moment of the results of that. So, to start with, it isn't a cultural tradition that begins after birth. It's an absolutely biological response to being brought up in a society in which before we're born, we're already hearing sounds. We respond to music in a way that we do not respond to speech. You did 3 months before you were born. Interesting one here. Mothers, lacking body hair for infants to cling to, employ song to nurse at a distance. Now, if that seems crazy, I will explain it in a moment. Song could be a form of oral security blanket, what Winnicott describes as a transferable object. Lullabies are a human universal. Toddlers graduate to playing vocal and movement games with their peers. Older children, and we're thinking towards adolescence here, develop their own subversive repertoires, a vital component of personal creativity. Parenting, the realization that you're going to have a baby, whether you're the father or the mother, if you're in a relationship where you're both involved, there are reports of it releasing the latent musicality. Even in people who didn't think they could sing, they start singing to their babies. Song can remain an effective form of communication even after language is affected by conditions like dementia and Alzheimer's. So we can lose language but still respond to and participate in singing. These factors indicate adaptation on Darwinian lines rather than cultural affordance. We should bear them all in mind in considering the vital role that singing still plays in human society. Let's go back to Darwin. One of my favourite things was that in order to define instinct, which is a terribly important part of his theory, he turns to a musical figure. If we suppose any habitual action to become inherited, and I think it can be shown that this does sometimes happen, then the resemblance between what originally was a habit and an instinct becomes so close as not to be distinguished. If Mozart, instead of playing the piano at 3 years old with wonderfully little practice, had played a tune with no practice at all, he might truly be said to have done so instinctively. So let's just place these things again, the aspects of research that we're going to consider as evidence of musicality as an adapted phenomenon. I call these the life cycle aspects of vocalization. In utero responses to eternal musical stimuli and to the mother's voice, the baby's first cry, when we were born, doctors looked for our first cry as sign that we were alive and able. Dyadic interaction with the mother, first evidence of the capacity for unison. People have worked really hard on whether babies can match the pitch of their mothers. They can. Caring at a distance, song as a means of mediating separation anxiety, play, attachment, and social bonding with siblings and peers and within the family group. Development of rebellious or individualistic traits in singing, standing out from the crowd. So the thing that can make us all work together so well is also available for us to contrast with one another and disagree. unison and ritual. And here we look at the role that music might play to some extent in religion, prayers, oaths, community singing, but also singing at football matches, these sorts of things. Vocalization in mate attraction and retention, a very important part of how Darwin first expresses it in The Descent of Man. Song as therapy in old age, when a condition such as Alzheimer's affects the verbal system but leaves the song system relatively intact. Just a quick word about pitch and timbre. I'm sure you know these things, but when we talk about pitch, we're really referring to this salient frequency, the fundamental F naught there, that is perceived, and we usually measure in hertz. When pitches combine to create more complex signals, these may be perceived as formants. So we're looking at the question of whether pitches go together, consonants, or fight with one another, dissonance. And this is to do with frequency relationships. On the whole, consonant relationships are very simple mathematics. 1, 2, 4, 6, 8, well, 1, 2, 4, 8, 16, and so on. Complicated ones are ones where there is less of a mathematical clarity to the relationships. And these features present the timbre of the sound. Thus, pitch and timbre, in terms of the way that our oral system and our neurology has evolved, they're closely related and mutually influential on how a sound is perceived. So as we shall see, variations in timbre can arise from the musical properties of vocal sound. So pitches can be perceived as vowels, and we'll see that idea of language with its vowel sounds emerging from an existing capacity to sing explains one possible theory that we can apply. Okay, I can't sing that. Any cellists in the room? That's I wrote as the harmonic series of the lowest note of the cello, but I can't sing it, so I'll have to transpose up a bit. But at least in this diagram it illustrates. So I could take a low note like this. Now if I actually sing these, I'm rapidly going through my range. And then I find it quite hard to go further. But I can access those pitches by using harmonics. If I do it slowly, can you count which one you think I'm doing? I'll start here. It's sometimes quite difficult to get that clearly different from there, but I'll try. Right, I'm now on. And I've run out of breath, so we'll move on. You just heard me, a human being, vocalizing these. I'd like to ask you to listen to this and see if you can tell me what you think is making these noises. Several miles away, but possibly people have analysed this and said you hear 6 other words. But this was done with a hydrophone right up where this was being done. Now, I don't know how many of you study harmony or play instruments where you use harmonics, but I just hear the harmonic series all the time in that. Can you put your hand up if you agree with me? You're hearing the harmonic series. Either that or you're very polite. Good. Well, I've actually analysed that. It's E flat major. I've played it to trombonists and to Australian Aborigines who play the didgeridoo, and I've played it to other people, like my friends who work with overtone singing, which they do much better than I can, and everybody says that animal knows what it's doing, and it is deliberately singing those harmonics because that's part of its learned capacity to play with the sounds it can make. Okay, your turn. I set this out like a spectrum. So we go, ooh, oh, 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 oh. You can hear the harmonics even of my voice. Let's try that. You do it this time. We'll take this as the pitch. Ladies, if you like, an octave higher. Okay, can we try and move at the same speed? Otherwise we get all harmonics at once, which is very nice. I'll compose it later, but okay. Good, it's there. I have the advantage of the microphone, obviously, so I can make them very clear. And anyway, there are reasons why I could teach you, but not today. But what you could hear is that each of those distinct sounds was pretty similar. And I've never done this in Poland before, so I heard attempts to produce all those. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different vowel sounds. Would you normally think of Polish as having 11 sounds, at least? Yeah? About. Okay. So I've written an explanation of this. The work of the Paris-based Vietnamese voice researcher Trung Quang Hai has illustrated the cross-cultural manner in which musical techniques such as overtone singing in Tuva, Mongolia, and South Africa illustrate implicit knowledge of the harmonic series that maps onto vowel perception and production. See also the exploration of this perspective on overtone singing, Jews harp performance, and East Central Asian languages in the works of musicologist Alexei Nikolsky. And I would add that the Aboriginals in Australia who play the didgeridoo fully understand this, that when they're playing the different harmonics, they are hearing them as language. So I'm going to go back now to the life cycle issues, because I think this really helps. The American psychologist Dean Falk devised this theory of the use of music to nurse at a distance. So let's consider the implication for parenting. And I've done this really with slides that I may explain a bit. That's my grandson. He's now 9 years old, so he doesn't look or sound like this anymore. I didn't want to play him the sound. I didn't want to play you the sound of him. So instead, I got an example. This was recorded under Sheila Woodward's research project. This is from inside the womb. This is what the baby at about 10 months gestation hears of its mother. Can you hear the mother's heartbeat? So we're talking about comforting babies. This is an orangutan infant. Now, these live in trees, so if they can't hold on to their mother's fur when the mother's climbing the tree, they die. We still have fear of falling as one of our primal instincts. It's one of the things that doctors test the moment you're born. Do you make a sound, cry, and do you respond in that particular gesture to them pretending to drop you? You won't remember that, but your parents will. Ask them. This is a slightly older orangutan that's found a different solution, holding on to the head hair. Now, a human baby could do that, although they don't, do they? But hairiness is part of defending your child in physical proximity, especially if you're a tree dweller. That's another solution. Have a pouch. Here's a human response to that solution. The kangaroo's pouch represents an evolved marsupial solution to where to put a helpless dependent baby. What alternatives have been offered by human culture and tool making? So, in this case, the Navajo lady from the western coast of America, she can have her child and she can use her hands to cook, to make clothes, to work. This is my daughter with the little baby, slightly older, that you saw in the previous picture crying. That's another thing, we all do this nowadays. So we can sort of invoke the replacement to the orangutan and chimpanzee's hairiness. So Dean Falk said that hairless human females no longer offer to their young the physical anchors that safely allow them to work while looking after the young. Fear of falling is one of the strongest physical reflexes in human newborn infants, tested by medical professionals to check normal muscular and neural function at birth. Vocalization permits mothers to tend their babies while foraging and carrying out other tasks. The nursing at a distance hypothesis. And we've even now got possible evidence in fossilized footsteps here from Tanzania. These are 3.66 million years old. If you look closely at the feet, you can tell that a child is desperately trying to keep pace with an adult. The large adult feet close together in their footsteps, the little child's feet requiring them to, do this to stay in time. Many of the song traditions of Southern Africa that have been studied by my friend Pedro Espy Sanchez use song to keep people amused, because sometimes when they're migrating from one area of food to another, they might be walking for several days. And he calls this the effect of song being the earliest form of public transport. Okay, now if you've got the little child trying to keep pace when making those footsteps, you've got a difference of scale. Two people working together with different anatomy. And obviously, coming back to the gibbons, with the male and the female so clearly distinguished, this is a defining feature of us in this room right now. We heard it when we were singing just a few minutes ago. We call this octave equivalence, and we're going to consider why it matters. It's the phenomenon whereby pitches that are separated by a 2-to-1 frequency ratio are experienced as the same. I'm going to ask the men in the room just to sing a note. I'll give you ah. Okay, one or two of you singing different notes to me, but that's okay. It's the range that we're considering. Now, girls only. Now, you might say, well, that's cultural, it's obvious. Of course, we're going to do that. We were told to, or we sang it like that at school. I think it's an evolved phenomenon. Octave equivalence has been detected in species other than human. For example, in the pitch perception of Japanese macaques, and in the vocal response of a dolphin to synthesized musical stimulus. Now, we're talking there about perception of notes and octave apart as being the same. We not only perceive it, but we can also use it in voice production, as we do in language and in song. All the indications are that it's a human universal, and also a defining adaptive feature of human vocal organization. So how might octave equivalence have become universal and significant? The candid explanation is that it represents an adaptive response to the properties of the harmonic series. Remember, we sang the harmonic series and illustrated the relationship with vowels. It's evident in instinctive, perceptual, and productive features of human vocalization. This is the theoretical position, which will now be examined and experienced in what follows. The evolutionary bridge between animal calls and modern human vocal communication involved anatomical and psychological adaptations that exploit instinctive responses to harmonic sounds. Reactions to sound are detectable from fetus in the womb onwards, and they shape human pitch processing from infancy through interaction with the sonic environment, through play, through imitation, and through the specific parameters of acoustic control that underpin human vocal learning. So we have pitch. You can just copy this. It doesn't have to be precise, but just so you understand the words we're using for these different parameters. This is pitch. Ah. Ah. So that has meaning. There's a difference between up and down. Okay. Duration. There's a difference between up and ah. And you can make combined you can have long and short combined rhythm. Amplitude. Timbre. We've done timbre already. It was the vowel sound. Okay, so those are our parameters. By the way, there are only 4. Every now and then I come across people who ask me, but surely this, and it's one of those parameters that they haven't realized works. There are only those 4 in music, in acoustics generally. Previous work on the phenomenon of singing has focused on the relationship between phylogeny, that's the development of the voice in our species, going back millions of years, and ontology, your personal vocal journey that each of us experienced. And this suggests that each of us passes through stages in our lives that parallel the acquisition of vocality in our species. Such a development pathway has been viewed as representing the contrast between weak and strong Darwinism that we've already encountered, and which remains the cause of controversy in the perspectives of different disciplines addressing the topic. So I'll just repeat these two, and I'll be interested, maybe in question time, as to whether anybody's opinion has changed. 50 years ago, most people in a university would have thought this. Music evolved as a side effect of the interaction between general intelligence and culture, and is thus dependent on an existing capacity for language. Now, as I go around the world and I meet wonderful people like your teacher and friends in different countries, I'm finding more and more people accepting this. Musical behavior evolved prior to language due to anatomical adaptations in response to the environment that conferred advantages in vocal communication and perception, without which our species would not have survived. So, a few more ways of looking at this. I'm going to go back to fossil evidence briefly. We've looked at the evolution of the skull shape, and I would simply go to say that the human skull is a musical instrument. It is like a drum. It resonates. I've actually done this, but probably not today. But in fact, if I got you all to sing really loud, you could actually feel the vibrations in various places. Here, the back of the skull. Has anybody held a baby's skull while it's crying? You feel the vibration. You have. Good. Nice to get some.
I have a younger brother, so a lot of that.
Right. And you know, our skulls are part of our musicality. They respond to the signals we send to them to amplify. So, I don't know where that came from. Here we go. And just a little bit more about what I call the software, because when we look at the fossils, we're looking at bones. There's lots they don't show. This little bone, wherever it's gone, it's behind there, the hyoid bone. For 100 years, they'd never found the hyoid bones of early fossils because they're a detachable bone and they would have disappeared. Since I began this work, I think about 10 years ago, they found a Neanderthal hyoid somewhere in Israel, and it's made its little contribution to the success of this view. So we know how our bodies work, I'm sure, but I just throw that out because these are the features which we have to consider and test in looking at the story of how we vocalize with upright posture, with a dropped larynx, because the distance between the larynx and the lips is greater in human beings than it is in any of our nearest relatives like chimpanzees, orangutans, gorillas. That has clearly happened because of upright posture. Which came first and how is what people are looking at. So we now have two crucial questions. Why are the voices of adult males, on average, an octave lower than those of children and females? And how does that question relate to the overall picture? And what acoustic relationships shaped the timbral character of vowel sounds? So we'll just return to these two topics. Are all human voices descended from a pitch originally shared with the adult female? People have referred to this as Eve, mitochondrial Eve, somebody, a lady living in Africa, possibly 300,000 years ago, from which everybody in this room, including me, is one way or another descended. It's not a biblical story, it's to do with DNA and the transmission of certain genetic features that can be traced right the way back to that. What this would suggest, therefore, is that that mitochondrial lady was impregnated in order to reproduce by an adult male who actually shared the same vocal range. And that since then, in that long journey, it's the male voice that has dropped. So the biblical explanation that women are a secondary creation after the man was made doesn't quite add up here, in that the sounds that we can clearly tell we all make together now are the results of sexual selection. Now, the women played a part in that because, if you remember, sexual selection is partly to do with the object possessing features which are preferred. So it's not just that the men wanted to get lower out of reasons of dominance or competition with each other, but the females perhaps chose and helped the breeding of the males who possessed the best response to that phenomenon. However, if that's the case, why did they stop at the octave? And this is the crucial thing to think about. The octave permits us to agree. It permits us to consonantly perform with each other and, critically, therefore, to amplify. If a man and a woman sing the same notes an octave apart, you get more than two voices. You get the impression of 3-4 voices. This is referred to sometimes as the Beau Geste effect. If you know the book by Wren about the people who were trying to defend a fort by putting dead bodies with muskets to look as if they're still able to shoot, in the novel Beau Geste. And it's a way that it is suggested human beings protect themselves against predators and against other humans by pretending there's more of them to fight. And they do it vocally.
Like the turtle formation in the Roman legions, for example.
It's a good example, yes. Although that's largely done with parts, with weapons outside the human body. Whereas what we're talking about is purely within everybody's bodies. Thank you. So children respond instinctively to vocalization before birth and then learn, even this early, repertoires that they later remember. They learn languages equally well from both parents, despite the difference in their ranges. There is no evidence that when children learn language, they try and imitate their father using words differently to how their mother does. Their perception must hear them as able to be imitated in their voice as the same, which, in my view, is dependent on an understanding of octave equivalence between the two things that they're imitating, such that they do not give you evidence of the range difference. Okay, so let's just go back to this. I haven't got a Polish version of this, but I'm sure you can manage. Can you just say these words for me? Okay, so let's have that nice and loud, and try and do it on the signal, so it's going to be boot, because if I get everybody to do this together, it'll make more sense. Yeah, that's these expressions. That's really B-U umlaut. In Scotland, they don't say boot, they say beat. We can leave that one out. Now, let's leave the buttons out. We go on a pitch. Okay, now do it again. 5 times louder. Big breath, really loud. Yeah, I can hear the harmonics. Good enough for me for the moment. So, emotion. I haven't talked about emotion much except for children and their comfort. I'm going to ask you, because you've proved you're now able to make sounds, to make the vocal sound that you associate with my face shape. Thank you. This is harder to do for me. Okay. Now, there was a singing teacher called Lucy Mannen who used these techniques as a way of restoring aging voices. Her finest pupil was a man called Peter Pears, who was the boyfriend of the British composer Benjamin Britten, who wrote the introduction to her book on this, citing her as having restored his voice so that he could sing the late works of Britten, like Death in Venice. I don't know if you know these operas, but Pears said that this way of experiencing the ideal emotion, which gave rise to the vocal sound, actually it kept him singing for an extra 10 to 15 years, where otherwise he was losing his voice. So what does that mean? It means that what Mannen has done is to connect the kind of vocal sound we're making to the feeling of making it. Once a singer can do that, they don't have to feel all these things and kind of end up almost schizophrenic by having to call on anger in order to sing or whatever it might be. But as a practice technique, it allows them to locate the sensations, remember the feelings, the vibrations in the skull with which each sound is associated. And beautifully, this recapitulates Darwin, the associated facial expression. How might such emotional correlates be explored in the interests of healthy vocal technique and, if you're working with choirs, achieving a more sensitive choral blend? Right, so I'm going to play you a couple of tracks now that may help to illustrate some of the things. These are both pieces of music recorded in the last 20, 30 years. Here we have a solo song, and just this has got a nice instrumental introduction played on a sort of guitar-like instrument, but listen to what the singer then does. Whee! Some of you may manage this. Let's just take an ordinary mid-range low note. Now listen carefully. This description may not work, but if I very gently put my finger and thumb around my larynx, I can invoke relaxation in the muscles that surround the larynx so that they release the kind of positioning. And the effect that that has is to allow the larynx to miss a frequency. So if it's halving the number of frequencies, you will get an octave lower. Everybody in this room has done this at some point in their lives, even if they didn't know. Now, I'm not anywhere near as Gennady Tumat, who's on the recording. But then, if you invoke harmonics as well, the harmonics come down the octave as well because they're responding to that fundamental. So I can go. You can hear the harmonics in that mood. These guys practice 4 different forms of that technique. They're from Tuva, which is sort of Russian extension of Mongolia, and they've made their reputations internationally now. You can hear recordings. I saw a few of you nodding. I think possibly some of you have heard this before, which is fine. That's a soloist. One of the things we're talking about is what happens collectively, and I'm going to play you another example without saying anything about it, apart from the fact that it's in chorus. Anybody in the room might like to make about what's different about this music. Anything you'd like to say? We can't be wrong. I'd just like to know what you heard, because I don't want to tell you what you should have heard. I want to know what you've heard. Yeah?
Maybe a few moments they were like tuning to one sound, like they were singing in unison for a moment. And
clearly there are unison moments where it's if the women sing and then the men join them, and then what happens? Because it's
they sing for a while in the same note, and then they just separate and sing different voices.
Okay, thank you. That's helpful. I think I've given the game away about one of the things that's unique, which is the women are in charge. I don't know of any musical style anywhere where men have to do what women tell them, apart from this. Tell me if I'm wrong. Second, I played this to conferences. I'll use the mic and I've played this example in conferences and thought sessions, and on several occasions people have told me, they were taught to do this by missionaries, i.e. the harmony these people are singing must have been learnt from Europeans because such people couldn't have had the harmony of their own. Can anybody tell me of any evidence that that explanation has to be wrong? Well, there are a couple of little glides in there, but the actual intervals are those of the harmonic series at almost every point, which is why I use this to support the position I've explained. Yes?
I would say it's also like more complex than the Western singing, I would say.
The harmony has more complex features than any Methodist or Christian missionary would have taught. Okay, I'm going to play it again because there's another absolutely fundamental thing. Let's cheat a moment. Imagine you're a Christian missionary with your harmonium or organ, and you set it up in a tent on an island, and you say you've got to play this. What is the first moment? I'm going to play the music. I want you to put your hand up when you hear something that would have scared that missionary, realizing that they'd either done a really bad job or these people could already do it. music has a significant feature which we are told from the moment we learn it, we have to abide by. What is it?
Rhythm?
Not the rhythm. Those rhythms are not, they're a bit syncopated, but they're not impossible to imagine. There is a feature of what happens to the pitch that breaks every expectation of the Western music that any missionary would have taught. Yes?
Maybe the end of unisolo is not exactly the unisolo. There is a small difference about it, and then there's a rapid just.
Well, I'll put you out of your misery, but you can get these on YouTube and so on. It's tonality. If we teach people music, we worry about what key it's in, how many sharps or flats. We think this is the keynote, and we push that forward. And we think about the work that people like Fuchs and Schenker did on establishing that as principles of how Western music is organized. The ladies here are playing a game. They are empowered to surprise everybody else in choosing a different key for each verse. So we have the and that, by the way, is the end of the previous session. It is not setting the tonality for the next setting, for the next section. Because what happens is that the lady soloist then changes key, and you can hear people immediately clicking into the new key and coming in with powerful chords that they didn't expect to have to make. That is why I think these people were doing this thousands of years before they ever saw a European. And that was both pieces at the same time for reasons that this computer knows that I don't. Okay, we're getting there. Is musicality a human universal or a culturally transcended behavior? As recently as 2019, a team led by Jacobi believed that they had proved that octave equivalence is culturally derived and not a human universal. Remember, despite the fact that it's in dolphins and Japanese macaques. And you heard it in the humpback whale as an expression of the use of the harmonic series. This conclusion resulted from experimental work playing high-frequency synthesized sounds to Amazonian subjects who had never heard them before and were unable to reproduce them vocally. Later reinterpretation of this data by the same team conceded that response to harmonic series properties is universal, but shapes different cultural practices. And I think that different cultural practice is what was evident in the ladies surprising people into singing in different keys in the example from Rapa Iti, which, in my view, is based on a tradition of their own that is very old. However, neurological examination of response to harmonic sounds has for some 20 years studied evolved sensitivity to related wavelengths that shapes human hearing and the feedback loop which permits imitative vocalization. So it's the brain scientists that have got the answer. They've proved that the neurological arrangement for recognizing and providing response to pitch is a fixed entity. It's in our anatomy. And we can probably now trace when that entered the human genome.
So like in languages, for example, actually the underlying word order than we have the underlying word order than we have in our brain is like verb object subject or something like that, but how it is expressed, it varies from language to language. So in this case, it might be something similar, like the octave equivalence is in our brain, but how it is expressed, it varies from.
You're absolutely right, and there are theories of the universality of human grammar, and that's a fascinating example. We in England don't say on the mat the cat's out, you know. But I think the theory and study of the anatomy and psychology would suggest that this is a much older phenomenon even than grammar. Let me just go on a bit. The work that we've just described has developed rapidly over the last 15 years, and it's happening right now in Japan and Australia, New Zealand. Scandinavia in particular, possibly in Germany as well. I think I know one laboratory that's been doing this. It's been replicated and extended in research across the world. We are a singing species. We are a singing species. First suggested by the great German, whose name completely escapes me, so I shouldn't have bothered to mention him, but there were two brothers and they explored Latin America together from Berlin. Shoot me now, bang. It'll come to me in a moment and I'll remind you. But he used the expression, the singing species. Humboldt, thank you so much. Even got a university named after him. We are a singing species because the capacity to be so is transmitted in our DNA. And I have to say, I was very lucky to be able to share writing that in a paper with Piotr Poletniak. So, that is a little diagram that illustrates everything we've talked about. I could either say something about it for half an hour or leave it. What have been the evolutionary advantages of singing? Pacifying infants, transmission of knowledge and culture from one generation to the next, attraction of mates and sustaining parental affection, collective defense against predators, social bonding within the family and with new acquaintances, a medium for creativity and play, raising pain thresholds in times of conflict and threat, a mnemonic to aid memory and recall information, and emotional memory that could give rise to nostalgia and coping with aging. If singing is an instinctive and universal trait of our species, how can we preserve its role today? All schools should ensure that children sing and should provide opportunities for them to acquire active musical experience. Pedagogy should promote creativity, instinctive musicality, and multi-sensory integration of the kind promoted in my harmony signing, which I'll do a session on Thursday. But there's lots of other things you can do, not just by work. The natural inclination of new parents to sing with their babies should be encouraged. You know, the medical profession could do something about that. They are doing in England. You can go to singing classes for new parents. Opportunity to sing should remain available in the funding of cultural and health policies, up to and including the potential of singing to preserve vocal communication amongst people whose language skills are threatened by dementia. The value of cooperative activities such as group singing should be sustained as a complement to the increasingly individualistic isolation that results from the use of mobile phones, social media, and AI-derived games and programs. The integrative health benefits of singing on mental, postural, respiratory, and social aspects of well-being need to be promoted. That's it.
Thank you very much for a very inspiring lecture. And now we have time for questions. So maybe I will share a microphone with people who want to ask questions, and then I will give it to Professor Banner. Who is the first person who wants to ask? I saw you.
You got a different thing.
Almost, but everything is didgeridoo, right? If you sing to it, right? Thank you for the wonderful lecture. I honestly have one question. Your slide that said software for singing showed the muscles and like the inside stuff that I would instinctively call hardware, and I wanted to know, why did you say software?
Great, and I apologize. Because I'd been showing you fossils and only bone and teeth fossilize. So muscles and tendons and all of the other things that wrap around muscles, I refer to for that purpose only as software. You're absolutely right. I should find a better way of doing that, because the real software is sound, intensity, the things that you do with them. Great point, thank you. Is that clear now?
So I have a question, because it was mentioned earlier that singing can be used in, for example, patients that have problems with speech due to dementia and so on, but they were people who were able to speak before they have had dementia. What about people who are, for example, nonverbal, like they do not possess the ability to speak at all? There are some conditions that make people unable to talk at all, and can all the very smart stuff that I heard be applied to, for example, children that are nonverbal and cannot speak at all?
Should be tempted to think. Yes, the answer is yes, and there is work. Now, I've not been involved with that, and I don't know it closely. I am aware of some problems with it, and I'll give you a slightly different answer after this, but I'll start with making the point that if you're non-verbal, and people have this condition, and we know, the chances are that the ways you do make sound will largely be emotional, and the difficulty is controlling the emotion so that it doesn't look as if the child who's probably trying terribly hard to vocalize is doing so in a way that the listener finds unpleasant. So there is a very complicated and elaborate way that this is done, about which I know very little. But you could look it up, and I think you would find some reassurance that this would fit, if you like, with the bigger picture. I will say a word about something quite closely related, and that is children born deaf, because I happened to be aware of one of the very first children at the age of about 2 to have a cochlear implant. And this went very well, and he learned to speak. However, the sad thing is that the surgeons who did that tried to put cochlear implants into the ears of people in their 20s, and they had to have them removed because the experience of that clarity of sound was so stressful that it was worse than using the alternatives of sign language and lip reading that they learned.
So my question. As you have said, Darwin very much liked music, and it was important in his theory. So, do you maybe know what Alfred Wallace thought about music? I'm asking this because actually the theory of evolution, as we know, actually owes more to Wallace's theory than Darwin's, in fact. So I thought maybe it would be like maybe Wallace's point of view would be also interesting in that case.
Yes, so my question relates to the fact that when Darwin first published The Origin of Species, in the presentation at the Royal Society before the publication, he acknowledged co-devising of the theory of evolution with Alfred Wallace. In fact, the reason he did this was he could have published The Origin of Species 20 years earlier. He daren't do so, partly because he didn't want to offend his wife, who was a very strongly practicing Christian, partly because he felt that he had to find more and more examples from the natural world, from mushrooms, from grass, from every single possible realm of the biological sciences, before he felt that the theory was sufficiently extensive for him not to upset the church in particular, but also scientists who didn't agree with him. So he acknowledged Wallace, and you're absolutely right, Wallace would have otherwise published independently, and there could have been a perceived tension between them. Wallace's then, his career went on to other things. Darwin went on to write about sexual selection, which wasn't the direction that Wallace went in. As far as I recall, and I'm stretching back to 30 years ago when I read about this, Wallace did have an idea about music because he was in New Guinea, I think.
I don't know that.
Well, the area of the world that Wallace investigated had got a strong musical tradition which was old, and he took that into account. But whether he actually theorized about it, I'm not sure. But what we have to recognize about Darwin's experience of other cultures, that the voyage of the Beagle visited a huge number of countries, and in every single one of them, he actually listened to music and made notes about it, some of which isn't in his work, but the inventor, if you like, or the first person to have a designated post in ethnomusicology, a scholar called Tyler, actually made use of Darwin's notations and descriptions of dance and song around the world as part of his evidence for the universality of music. So it's an interesting question, and I can't explain much about Wallace, but I think it's worth being clear that Darwin knew that it would be a struggle in his own lifetime to have his ideas accepted. For 100 years after he died, people were still rejecting his explanation about music, including musicologists. We are amongst the people who are trying to put that right.
I would like to ask one question, because you mentioned here a kind of as an evidence for the octave equality, the way in which children are studying language from the mother and father, and you're probably intended to put into the question there that the mother usually talk on the difference of the octave, but I think it is not the problem. It's not the case, because in music we surely have the octave relationship between singing, women singing and men singing, but in speech there are different tones on which the language is pronounced, the form, the spoken form. So there are also personal differences between particular people speaking, men and women, on different tones. So probably it's not the evidence that could explain this equality of octave, but maybe I have understood wrong.
Okay, the question is about really... Is that still on? Yeah. Oh, the question is about the idea that the child interprets sounds made by females, adult females and adult males, as if they're the same. And I think the evidence for that is actually even clearer in singing. I mean, if a man teaches a song to a child, and remember the child could have heard her father sing when it was in the womb, the child doesn't imitate the range, they sing an octave higher. I mentioned it in language terms to simply illustrate that they don't try in any way to replicate the range. Now, of course, language responds to emotion and prosody, so we sound completely different where we're shouting to friends from when we're whispering, and so on and so on. There's a huge degree of variety, and it's really important to recognize. I'll give you another example of an objection to the theory. If we sing in choirs, I conduct choirs quite a lot, we have sopranos, altos, tenors, basses. If you know the Verdi Requiem, beautiful Agnus Dei at the end, the two women sing an octave apart. I'm not alleging that there's a difference in genetic adaptation between sopranos and altos. That's a cultural matter. So that gives you an indication of there being an overlap between the anatomy and the way that requires us to respond, and the cultural attributes of people who've got lower voices finding that that's where they express themselves. Is that in any way credible? Okay.
Okay, so it's probably more of a recommendation maybe than a question, but have you heard of the Mamuna tribe of Papua New Guinea? So it's a collecting and walking tribe, and they make a very vocalizing songs when they walk, and they in their language they sing about only walking and like singing that the earth is their mother and the day is coming, like that kind of stuff. So I think it would be very appropriate to maybe include it in your researches. So maybe that's just a recommendation.
Thank you very much. I have come across people who've studied that. I haven't listened to those examples, but you've encouraged me to do so, and I can add it perhaps in future. But yes, it's very useful to hear this sort of evidence, because the examples I gave were from the work of Pedro Espí Sánchez, and I do know those. They're from Cape Town area, where the indigenous inhabitants live outside the city, from Namibia, from Botswana, Zambia, and Mozambique. To hear the same thing really occurring, like the music as the form of human public transport, to hear that coming from New Guinea doesn't surprise me at all, and it illustrates the potential universality of that as a phenomenon in social organisation. Oh, by the way, I should add sailors around the world who sing because if you get out of time, you can't do the job. If you're doing something as dangerous as pulling a rope in, the rhythm of which affects the lives of hundreds of people, you sing.
Who is next?
Okay, we talked about the role of vocal music in the upbringing of a child. Can we put those mechanisms in the case of like instrumental music? How that's relate to this theory?
Well, I'm biased, I know, but I would always, when I'm dealing with instrumental teachers, I would always encourage and hope that the child had learned to sing first, because so many of these skills are transferable to whatever the instrument is. I'll tell you a couple of interesting things, slightly randomly. One is that I was once invited to talk about all of this to the British Flute Association. So I did talk about all this. And it suddenly, I can't remember why, but it struck me that one of the things that somebody had touched on was about the neurology and the way that for most people the language centre is strongly in the left-hand side of the brain. Now on Thursday I'm going to try and ask people to switch that off so that they don't think in words and only respond if they're right-handed with the right-hand side of the brain, and that processes abstract sound. And so I said to the British Flute Association, there's 100 people here, all flute teachers, I said, are there any left-handers in the room? Now, I've asked that question in other sessions, and I usually get something like 5 to 10%. Not one flute player was left-handed. And I suddenly realised a left-handed person doesn't want to play an instrument for which nobody has made a version that goes the other way. Now, at the time of Monteverdi, he had two friends who were flute players. One played left-handed, one played right-handed. And we know this because we've got the pictures, but they didn't have all the key work. They just had holes, so it didn't matter which way you played, it still worked. I had another suggestion. So your question was about transferring skills to instrumentalists. Yeah, I can only now refer anecdotally to how people teach. I used to work a little at the Yehudi Menuhin School in London, which is where some of the finest young musicians around the world go to have a very intensive professional education. And I was very lucky to see the great American pianist Claude Frank teaching a masterclass on Chopin. And the way he taught was to sing along with the students. He never talked about fingering. He never said, do this. He said, could you make that phrase go more, ah, ah, ah? He sang as his way of teaching pianists. I'd like to feel every instrumental teacher might follow that example, perhaps. I didn't answer your question, but there's a couple of thoughts at least.
Who is next? Oh, of course.
One more question. That will be a rather stupid question because I don't know the answer. But in this presentation, in one of your slides, I have found out that we can hope that, or maybe even say that music was before, singing was before language as invention for the human beings. But what's your opinion about the tonal languages like Thai, Chinese? Are there more formal earlier, or maybe they have more emotions in them?
I'm not going to talk about emotion. I have a couple of friends who've addressed this very problem. My friend Lily Chen, who studied the learning of song in Chinese-speaking nursery schools in Hong Kong, according to whether people were first language English, first language Cantonese, or first language Mandarin. And she recorded them and talked to them and did all sorts of stuff. And the existence of tonal language does change the way that we conceptualize the relationship between words and music. And it's quite an interesting problem because they had to divorce themselves from the word meanings in order to sing the notes of the tunes. If they were going to learn a song in English and then sing the Mandarin version and they were Mandarin speakers, they had to switch off the tonal language. And I've known a lovely friend from Kenya who did the same study. They have 13 language groups in Kenya, including several tonal languages, exactly the same results. People can learn to sing songs which divorce them from the tonal nature of their mother tongue. But that's not the question you asked. What you were implying is if there's any impression as to whether all language may have been tonal. There are a couple of people working on that, and I don't know where they've got to, but I have spoken to them at conferences, and I think there is a sort of impression that, if not all, more languages were tonal that have lost that. I've even heard Japanese scholars specify that the original Japanese language may have been tonal but lost it. I'm a bit hesitant to say any more because I don't want to mislead anybody. But it's a fantastic question, and it has struck several of us on occasion. Yeah? Have you come across this one?
Yeah, but there are some counter arguments because children who develop languages spontaneously usually do not do this with tonality, with tonal languages. Yeah? So linguists quarrel about this.
I mentioned Lily Chen, and if anybody's interested in this question, her work has continued at the University of Southern California, University of Los Angeles, I think. She's in California now. When she was a child in Hong Kong, she was brought up Cantonese speaking. She didn't learn English until she went to school, at which point she realized that English isn't tonal. And I remember her telling me one day that this was fascinating because even as a child, she hadn't known that Cantonese was a tonal language. You just talk it. So when she did her research, she refers back to that childhood epiphany of realizing that languages can have these different properties.
So maybe now is time for my questions. I have to. You mentioned the correlations between vowels and emotions. Yeah? Are these correlations similar to the correlations between vowels, not only vowels, but also vowels and some spatial imagination, like in the Bouba-Kiki effect? This is a very simple correlations between the shapes that we see. So the angular shapes are usually associated with vowels such as O, yeah, the rounding shapes are associated with O, yeah, but angular with E, yeah. So is it somehow the same way of thinking, and do you know some research?
The answer is no. I don't know much about it, nor can really answer your question in any informed manner. But I will just go back to this, because you saw me when I did the little test of which vowel am I making. You can see that I cannot go through the harmonic series without changes in facial expression. I'll just do this again because I think this is a helpful point at least to make. That's the kiss. I only move my lips, and you can hear the pitch change. Now, when I teach this technique to people, because it does get used by composers, you come across people who try and do this. Whoa, and they try and go sideways. It doesn't work. So we've already got some kind of evidence for this principle. In fact, this only works if I retain a vertical relationship from the larynx, shaped by the lips, what's happening inside with the tongue. The moment I do this, I've lost it. In fact, when I teach singing now, well, when I have been teaching singing to children, I've really encouraged wah, 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 because the resonances are greater. Now, whether people are aware of that and it becomes an instinctive connection over this idea of angularity and roundness and so on, I don't know, but if that is found and explored, I think that might be one of the explanations, that whether we know it or not, we get a one-dimensional effect. You notice I can make the vowel E, but I can't make the harmonic associated with it. You could hear the harmonic in that. I can't produce it there. So there is a musical difference in the voice production according to whether the lining up of my vowels is vertical or horizontal. Best I can do, I'm afraid.
Yeah, thanks. May I have yet another question? You depicted the story. The question is related to your idea of, and Dunbar, the idea of the evolution of sexual dimorphism in voice. Yeah? You depicted the story from the point of the proverbial Eve. Yeah? But what about Neanderthals? Do you take into account that maybe this process started earlier and also Neanderthals possessed or are gifted with this sexual dimorphism? Or
I think probably yes. I'm not an expert on this bit of the fossil evidence, but 2 points. One is that, as far as I know, the Neanderthals would also be traceably descended from mitochondrial Eve. Or if not, they would be, well, it's a question of where you put it. One way or another, somewhere in the descent, we share a common ancestor, okay? And that's worth looking into. One of us can perhaps consider that and see if we can make any sense of it. In one of the articles that I wrote about octave equivalence, Robin Dunbar, the Oxford-based population psychologist, did try to set out the timescale. We don't know because people either ignored that bit of the paper or thought it didn't mean much to them. But one day, I think we'll have enough information. And I happen, a second reason, just 2 weeks ago, they found a Neanderthal skull, which was in a sufficient form of preservation to give us information about the size and shape of the nose. And now people are arguing about what the Neanderthal nose was for, because the old theory was it helped them live in Arctic climates by warming air. But they've now got enough information to say that theory doesn't exist. So when I saw a discussion about this on Facebook, I just said, has anybody considered singing? Because, as we know, listen, the nose is infinitely involved, both in the production of the sound and our self-recall of how it sounds to us. If you just try this, make a sound and then close your nose and open it again, you will hear yourself sound different. Just any sound you like, that, whatever, try doing it. Yeah, can I simply point out you have to be making a bit more noise than that to feel it? Loud. Hold the nose, let it go. I mean, we've been doing this since we were kids. You know it works. So would that have been part of the mechanism by which, well, my friend Stephen Mythen wrote the book, The Singing Neanderthals? He felt that they were the breakthrough point. I think there's a lot in the book that's fascinating. I'm not sure everybody agrees with his sequencing, but I am sure that Stephen will be on that case right now, finding out whether it supports his theory or not.
Thank you. So we have still time for questions.
maybe stupid question, but I have one. I just wanted to ask that I realized that this all lecture when you sing, there is always E note. Mi note?
Which one, pitch?
Yes, E, and we have there in Poland, if we reference to some pitch, it's always an A.
Okay.
And there was an E, and this is for me. Yes, and this is just the cultural difference, or I don't know.
It is purely to do with the fact that I've come to Poland with a little bit of a cold, and those felt like the noises that I would best make today. My singing today has not been good. I've done this talk from the point of view of the singing much better when I've been lucky on other occasions. So, do you have absolute pitch? You recognise?
No, but in my music school we were told they teach us how to just know where's the A.
Yeah.
So
I mean, people have tried.
I just know.
This is a very interesting issue. I don't have absolute pitch. I never have done.
But I'm just
Yeah, but it's interesting because at the Paris Conservatoire they also try and teach that. And in the work of Stephen Mythen, he has one place in the Singing Neanderthals where he speculates on whether absolute pitch might have been part of the human condition, because there is a real problem. I think, is it 5% of humans have absolute pitch? Less. It's not common, but when it's in somebody, they have it from birth. You could track it from, days into a child's life that they're going to have this. Whether you can teach it perfectly or not is problematic, but obviously you've survived that, so well done. But I don't want to be controversial about this, but I've always actually avoided it for a couple of reasons. One is I don't want people to visualize letters of the alphabet and notation. If there are people who haven't done it before, I don't want them to worry about whether they're right or wrong. I want to teach people just to do it. And the second reason is more specifically musicological. I've done a lot of work in early music where we've had to use a pitch standard different to A440. And it actually is easier for me. I remember once conducting a choir where we sang Messiah, and one of the tenors had absolute pitch and had to write flats in before every single note of the entire piece in order not to make mistakes. So for me, not having absolute pitch hasn't worried me, but if you've got it, you've got it. And it's interesting. If you go to a music psychology conference, there'd be 300 papers, and usually about 50 to 100 are about absolute pitch, because the people interested in researching it are not interested in anything else. And I go to some of those. But I've learned that there's nothing that really helps. Nobody's ever talking about its evolution, which is what I would be interested in, I'm afraid.
So last chance for ask some questions publicly. Okay, Łukasz.
Thank you for your wonderful lecture. And I'm wondering if, overtone singing, we have it in Central Asia and South Africa and other places. Do you know any theories about special conditions to be fulfilled to have it? Is it cultural thing, like cultural diffusion, or maybe we have some theories about special conditions to appear overtone singing?
Well, I didn't say this at the time, but the really interesting thing is that the difference between the people in North Southeast Asia, that's the Mongolians, the Tibetans, the Tuvans, is that conventionally it was a male activity. There are examples creeping out now that the women used to do it secretly too, but they were never given the opportunity to perform in public, even though they acquired the ability. So, of course, now you are finding Tuvan ladies getting concerts and they can do it. But the real contrast there is the people who do it in Cape Town and Southern Africa are the women. I think it would be reasonable to say that while it may not have a spiritual dimension in terms of a belief structure or a sort of prompting that relates to liturgy or whatever, I think there is what you could call a sense of awe, because the person who's doing overtone singing is becoming two people. And the version that Gennady Tumak sang from Tuva, that is showing a sense of play, but also a sense of empowerment. I can do this, it's interesting. The people like Madasini in South Africa who do it usually present it as an accompaniment to other singers. It's a way of being a drone, like a bagpipe drone, with a harmonic identity that helps other people to sing well. So we've got a different function, and that's as much as I can really say, I think. I certainly do feel that the best Tuvan work has, if not a spiritual dimension, a sense of something magical, something slightly superhuman, which they're aware of. I don't think that's what happens in the Southern African singing. I think it's much more naturally generous and helpful to your friends. How it's transmitted and why these pockets are so separated, I don't know. I have a suspicion, which Nikolsky follows up, that just as we were talking about whether all languages might have been tonal, Nikolsky feels that possibly overtone singing was part of the repertoire of song before language as well, and that the rest of us have just done other things. We've invented instruments and we sing along with them without needing overtones. I don't know. It's a fascinating area which maybe some of us will cover at some point.
So, yes, we are over time. So, thank you again, Professor Banan, for your fascinating lecture. This is not the end of the visit of Professor at our department, because on Thursday we have a special session devoted to presenting and teaching singing using your invented by you method of singing. So everyone who wants to get to know this method and meet Professor Banan again, feel invited to our meeting at the same time at 12 a.m. Here in the same room on Thursday. So thank you for your presence today, and thank you again, Professor Banan.
But also your wonderful staff in this institution for making me so welcome and making it possible to come. Oh, thank you very much. It's lovely to see everybody.